PR.9 Polynomial Inequalities. Southwestern College, Professor Maria Olivas. PR.9 Polynomial Inequalities. Objectives. Solve polynomial inequalities algebraically using a number line approach. 1. Solving polynomial inequalities in one variable, algebraic method. Definition. A polynomial inequality in one variable is like a polynomial equation, but instead of the equal sign, it contains one of the following symbols: less than, greater than, less than or equal to, greater than or equal to. For example, you could have something that looks like this: 2x squared minus 7x is greater than 4. First, I'm going to draw a vertical line segment going down to separate this polynomial inequality that I wrote on the left-hand side of the screen from what I'm writing on the right. I'm going to write down the inequality symbols, and I'm going to write down the way we say them. So the first one I wrote down was the less than symbol. The second one I'm writing down is the greater than symbol. The third one is the less than or equal to symbol. And the last one I'm going to write here is the greater than or equal to symbol. To solve a polynomial inequality, find all of the values of the variable which, when substituted, make the inequality true. Since there are usually an infinite number of values, we use interval notation or set builder notation. The algebraic method. Step 1. For polynomial inequalities, rewrite so one side of the inequality is 0 by adding or subtracting terms to both sides. Step 2. Solve the related equation. Change the inequality to an equal sign for the critical values. Step 3. Draw a number line and plot the critical values. Use open circles or parentheses if the inequality is less than or greater than. Exclude the critical values, and close circles or brackets if the inequality is less than or equal to or greater than or equal to. Include critical values. Step 4. Test the intervals between the critical values by substituting a test point into the inequality. If true, the interval is part of the solution set. If false, interval is not part of the solution set. Shade the intervals of the number line that correspond to the solutions. Step 5. Write the interval or intervals for the solution set using left bracket or right bracket for closed circle inclusion and left parenthesis or right parenthesis for open circle exclusion, connected by union symbols if needed. Examples. Use algebraic methods to solve the following polynomial inequalities. 1. 2x squared minus 7x greater than 4. So I rewrote the inequality 2x squared minus 7x is greater than 4. I am going to go ahead and I am subtracting 4 from both sides so that I have 0 on one side of the inequality. So now I have 2x squared minus 7x minus 4 is strictly greater than 0. Now, in order to find the critical values, I'm going to replace the inequality with an equal sign. So I'm going to go ahead and write the inequality 2x squared minus 7x minus 4, but instead of an inequality, like I said, I'm going to replace that inequality with an equal sign. So now it's actually going to become a quadratic equation. So it'll be 2x squared minus 7x minus 4 is equal to 0. Now we're going to solve this equation, and that's going to give us the critical values. I'm going to use the magic x method here to rewrite this trinomial as a polynomial with 4 terms. So this quadratic is written in the form ax squared plus bx plus c. So I'm going to draw an x to the right-hand side here. So I need two numbers that multiply to give me -8, which is 2 times that -4. And then I need two numbers that add up to give -7. So those two numbers are going to be -8 and +1. So we're going to have 2x squared minus 8x plus x minus 4 equals 0. I'm going to do factoring by grouping. I'm going to group the first two terms, the 2x squared minus 8x, and I'm going to group the last two terms, the x minus 4. I'm going to factor out the GCF for each one of those groups. So for the first one, I'm going to factor out a 2x, so it'll be 2x times the quantity x minus 4. Plus, there is nothing in common here with the x and 4 except 1, so I'm just going to factor out a 1 from the x minus 4. And when I factor out the x minus 4, I will end up with the quantity x minus 4 times the quantity 2x plus 1 equals 0. And now we set each one of those factors equal to 0, x minus 4 equal to 0, and 2x plus 1 equal to 0. In the x minus 4 equal to 0, I'm going to add 4 to both sides, and I'll get x equals 4. In the 2x plus 1 equals 0, I'm going to subtract 1 from both sides, and then I'll get 2x equals negative 1. Then I will divide by 2 to both sides, and I'll get x equals negative 1/2. I'm going to draw a vertical line segment separating the work that I did here on the left-hand side of the screen from the work that I'm going to do on the right-hand side of the screen. I have circled the critical values of 4 and negative 1/2. I've drawn arrows pointing towards both of them, and I'm labeling those with the words critical values. I will be using those critical values to create my number line. So I have created here a number line, and I have labeled in tick marks. The first tick mark that I drew more towards the left was the negative 1/2, and the tick mark I drew closer to the right-hand side of this number line is 4. Now what I'm going to do here is I'm going to choose test points in order to substitute into my inequality to see whether I get a true or false statement. To the left-hand side of the negative 1/2, so basically we're talking about the open interval from negative infinity to negative 1/2. And I know I'm looking at an open interval and also here because I don't want to include that negative 1/2. And when I represent my solution, I also know I want to maintain an open circle at negative 1/2 because if you look back at the original inequality, there's no equal sign. So I'm going to go ahead and draw an open circle on the negative 1/2. I have circled my inequality, the strictly greater than symbol. I have drawn arrows pointing from my inequality to my open circle, and I wrote no equal sign. And I did the same thing for the value of 4. I did an open circle on 4, and I did an arrow pointing towards the 4 from my no equal sign arrow that was pointing towards my inequality. I wrote the words open circle. So for the open interval from negative infinity to negative 1/2, I'm going to choose the test point of negative 1. From the open interval from negative 1/2 to 4, I'm choosing the test point of 0. And from the open interval of 4 to infinity, I'm choosing the test point of 5. I have circled my test points. So I have the test point of negative 1, 0, and 5. I have arrows pointing towards those, and I've labeled them with the words test points. Now we're going to go back and we're going to substitute these back in. We could use the original inequality. We could use the inequality where we have 2x squared minus 7x minus 4 is strictly greater than 0. I could even use the factored form of that polynomial on the left-hand side with the inequality there. So you have a choice here which inequality you want to choose to substitute into. So what I'm going to do first is I'm going to draw a green cloud around the 2x squared minus 7x minus 4 is greater than 0, and then draw an arrow from that cloud pointing towards the right. I'm going to copy that inequality down to show we could use this inequality right here. So I'm copying down 2x squared minus 7x minus 4 is greater than 0. I'm also going to write beneath it the factored form of this polynomial as an inequality. So I'm going to go and now I'm going to put a cloud around the factored form of the inequality. When it was written as an equation here, it was the quantity x minus 4 times the quantity 2x plus 1 equals 0. I put a cloud around that, and then I drew an arrow pointing up towards right beneath my inequality that I just copied down. So now I'm going to write this as the binomial x minus 4 times the quantity 2x plus 1, but instead of an equal sign, I'm going to put strictly greater than 0. So we could use either one of these inequalities to test our test points. Either one would give us the same results. So I'm going to start off by substituting x equal to negative 1. So I have copied down x equals negative 1, and I'm going to use the factored form for this polynomial inequality. I'm going to write inside parentheses negative 1 minus 4, and then times, I'm going to open up another set of parentheses, 2 times negative 1 plus 1, close the parentheses, and this is going to be strictly greater than 0. Well, I don't know if it's going to be strictly greater than 0. We need to check and see if this comes out true or false. So then we're going to have negative 5 times the quantity negative 2 plus 1 is strictly greater than 0. I don't know, maybe. Negative 5 times negative 1, is this going to be strictly greater than 0? Yes, it is. We are going to end up with positive 5 is greater than 0, and it is true. Therefore, I'm going to highlight that interval on my number line in green. So I've gotten my green highlighter, and I've highlighted everything to the left-hand side of that open circle at x equal to negative 1/2. I've drawn a vertical line segment here to separate the work that I just did right now for my test point for x equal to negative 1, and now I'm going to test x equal to 0. So once again, I'm going to use the factored form, but I think it might have been easier looking at this now if I had used the previous form, the one that was not factored. But that's okay. We're going to have 0 minus 4 times the quantity 2 times 0 plus 1 within parentheses. And we're going to check and see if this is greater than 0. So here we're going to end up with negative 4 times 1. Is this greater than 0? And we end up with a false statement because negative 4 is not greater than 0. So since it's false, I've written the word false next to negative 4 greater than 0. And I have drawn like an X across that interval where X is equal to 0. That open interval from negative 1/2 to 4, I do not want to shade that in. And then I'm going to draw a horizontal line segment here, separating the work that I just did right now where X is equal to 0. Now I'm going to substitute X equals 5. So I'm going to get, for the first set of parentheses, 5 minus 4 times, I'm going to open up a set of parentheses, 2 times 5 plus 1, close the parentheses, and we're checking to see if this is greater than 0. Next, we're going to have 1 times the quantity 10 plus 1, and once again, we're checking to see if this is greater than 0. And then 1 times 11, is this greater than 0? We get 11 is greater than 0. Yes, it's true. I'm going to write down the word true next to that. I'm going to go ahead and shade all of the values on the number line that are to the right of x equal to 4, where that open circle at x equal to 4 is at. We're going to shade everything to the right with my green highlighter. And I've gone ahead and I've written the infinity symbol at the right-hand side of my number line, and I've also written the negative infinity symbol at the left-hand side of my number line. It's going to help me write the answer in interval notation. So in interval notation, this is going to be the open interval from negative infinity to negative 1/2, union open interval from 4 to infinity. Or another way we could write this in set builder notation would be the set of all x such that x is less than negative 1/2 or x is greater than 4. And those are going to represent our solution sets. I've boxed in my answer and we are done with that problem.